In this video, I want to talk about the second, if I can write this, second derivative test. Second derivative test. I've already taught you, and we have looked at several examples concerning the first derivative test. And what was first derivative test meant to do? Well, it was used to find the relative extrema of a function. And if you remember how to apply the first derivative test, we first found f prime, and then we found the critical numbers where f prime is equal to 0 or undefined, and then we constructed a sign chart with the critical numbers put on the chart, and we determined the sign of f prime at its point separated by the critical points in the chart. And this gave us where the function was increasing, where the function was decreasing, and this told you where relative maximums or minimums lied. And that's how you use the first derivative test. And today I'm going to introduce you to the second derivative test, which is also used to find the relative extrema. But in this case, we are not going to use the first derivative. We're going to use second derivative of a function. So how is this going to work? Before I show you any examples, I don't think I might show you an example in this video. Let's think about the intuition behind it. If you think about it, let's say you found a point. Let's say you found a point where f prime is equal to 0, and this occurs at x equals to c. How is the graph of the function going to behave at x equals c or around x equals c? If you think about it, since the slope is 0, one way the graph can go is like this. Because the slope is 0, the tangent line at x equals c is 0, and the graph curves up like a parabola. Or the graph can curve down like a parabola like this. The slope is 0, and the graph is curving down. Or the graph can curve like a cubic function, like x cubed. The slope is still 0, but in this case, you do not have absolute extrema. In the first case, you have absolute minimum. In the second case, you have absolute maximum. And in third case, you have neither. And so, okay, if f prime is equal to 0, you can have extrema or you don't have to have an extrema. We already know that. But how is this going to help us? What's going to help you is the second derivative. Second derivative. If you remember, if the second derivative was positive, that means the graph of f was concave upward. And whenever the graph is concave upward, it is shaped like a U, with tangent line lying below the graph or the graph lying above the tangent line. If f double prime was negative, the graph was concave downward, and we know concave downward looks something like this. The graph lies below the tangent line, or the tangent line lies above the graph, and the graph looks like an upside down U. I already told you, easy way to remember is concave upward is a smiley face, while concave downward, because you're downhearted, is a frowny face. Now that we know this, how is f double prime combined with the fact that f prime is equal to 0 at x equals c going to help us? Well, if f prime is equal to 0 at x equals c, and f double prime was positive, that means the graph goes like a U, and that means you have the relative mean, like in this case, because that's the way the graph is going to be shaped like. If f prime is equal to 0 at x equals c, and f double prime is negative, you know the graph is going to be like an upside down U, and that's going to give you the relative maximum because it's going to be shaped like this. Okay, so if f double prime is positive at x equals c, where f prime is equal to 0, the graph has a minimum. If f double prime is negative, the graph has a maximum. But there is an important thing to consider. What happens when f double prime is equal to 0? In this case, you don't know how the graph is going to be shaped like. It might be shaped like this, it might be shaped like this, it might be shaped like this. We do not know. So in this case, the second derivative test fails. And in this case, you have to go back to the first derivative test and apply that instead. In the next few videos, I will show you some examples of using the second derivative test to find the relative extrema.